Hello and welcome to Physics Problems One by One.
So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself.
Another problem from playlist Momentum. Look into description, find the link, look for the previous problems in this playlist. This problem is also like a previous one about the boat. So there is a boat and there are two fishermen here and here, and mass of the boat is 200 kilograms. And this is M1, and this is M capital, and this is M2. And first fisherman is 80 kilogram, and second fisherman is 10 kilogram bigger, 90 kilogram. And of course they give us the length of the board, L, they say 6 meters. And then what happens, those guys are change places. So this walks to the tail and this walks to the nose. And notice, all we need to know that they change places. We're not interested in the process of how this walk first, this walk second, or otherwise, or they walk simultaneously. Doesn't matter. All that matters that this guy ends here and this guy ends here. And they want to know us how much the boat moved in the water. And of course it's again the problem about the center mass. So we have the first body, we have the X, and we have 0, and this is where the first guy stands, and this is where the second guy stands, and this is L capital, this is where the length of the board, and this is, let's say, A, the center of mass of the board, which is M capital, is here. And this is original situation. And then final situation is the same X, the same 0. And let's assume that the board moved and we don't know where it moved, forward, backwards. Let's assume, as always, when we don't know where it moves, let's assume that it moves in the positive direction. If we don't know the speed, assume it's positive. The sign will tell us that if it's negative. So let's assume that the boat now moved here. So this is L lowercase, small. L capital is the length of the board, and L lowercase is where the tail of the board is located. And if it's located here, the guy with M2 is located here. The center of the mass should move the same distance. So this would be M capital, and this would be A plus L. So it was A, but the whole board and moved the L meters forward, so this coordinate became A plus L. And the nose of the board, the coordinate became L plus L. And who is located here is the first guy, M1. And so we can say the center mass, in the beginning, it's M1 plus M2 plus M. And here are weighted averages, and let me draw it a little bit higher so not too crowded. L plus L. And now I apply this formula to this case. So it would be M1 multiplied by 0, so it will be gone, plus M capital, this coordinate is A, plus M2 multiplied by L, because this coordinate is L capital. And now what happens then? After it moves, this would be M2 multiplied by L lowercase. The second one would be M capital but the coordinate would be a plus L. And the final one would be m1, this mass, multiplied by this coordinate would be L plus L. And of course the bottom would be the same. I don't want even to write it, but okay, I write it. M1 plus M2 plus M. And this is the system, and this is physics is over. X center mass is first unknown, and L lowercase is second unknown. And how we solve it? We exclude X center mass, we say that this equals to this, and I can write, and I don't want even to write denominators because those would be two fractions with the same denominators. So I can say that this equals this. Because I am lazy, I don't want to do too much. So I say m1 multiplied by 0, 0, ma plus m2 L capital equals all this. So I2 equals m2 L lowercase plus, and I open the bracket, m a plus m L lowercase plus m1 L plus m1 L lowercase. So this is one equation with one unknown, and this unknown is L lowercase. Everything else is given. Mass is given. A is not given. Sorry, A is not given. But A will be successfully disappearing here. True, I forgot to say that there are three unknowns. But A will disappear here. We will see this and this will cancel out. So, let's try to solve it. We have to move everything with L in one and everything without L in another. So I write MA, because it doesn't contain L lowercase, plus M2 L stays, and I move here. This stays on the other side because it contains L lowercase. This moves here, minus MA. I could have cancelled them right away, but I will cancel them here. M2 L capital. This moved. This is another one. Stays, and this moves here, so and changes the sign. M1 L capital equals, and everything else contains M2 L. This is gone because it's moved. This should be here, ML lowercase. M1L moved, it's already accounted, and the last one plus M1L. Of course, this will be gone. L would be factored out, and let me first write this side first, as always, and it would be factored out. M2 plus M1 equals, and now I'm writing this side, and this side will be L would be factored out, M2 minus M1. And accordingly, L equals L, and this would be M2 minus M1 divided M1 plus M2 plus M. And you see how I wrote it. I put this fraction mass over mass, and that's good because it doesn't have any units. No matter what units, as long as they may be all in tons, all in grams, they all be made in kilograms, but they all will be gone as soon as this is the same units. It's a fraction, and so we may tell right away that this is the only fraction of this length of the board would be our final move of the boat against the water. Another thing is very important, and it's very good. You could be tempted to put the numbers right away here, everywhere. then you would not see the whole meaning of this. The whole meaning of this is m2 minus m1. So, first of all, this is the total sum of the system, this is closed system, and total sum of the system and denominator, and it's good because it's like symmetrical. And then m2 and m1, yes, if they change, this would be m2 minus m1, and they change again, it would be m1 minus m2. So it's very, very logical. And if you want to put the numbers, you always can put the numbers here. L is 6, m2 minus m1 would be 10, right? And in the bottom it would be 80 plus 90, 170 plus 200, 370. And so we will have 6 divided over 37. So very roughly it would be 1/6 of a meter. So it actually moved very, very little. It's like 15 centimeters of 6 inches, right? Half a feet. So basically, very small distance. And all because those two guys are the same mass. If those guys would be the same mass, this would be 0. And there would be no movement. And of course, that's true. There should be no movement. And again, it's very important that it doesn't matter how particularly they move. This first, in the end of the day, all of this, that's important in this, and that's all about this problem. So as usual, like, subscribe, bell, put your comment, ask your questions. Thank you.